just to warm things up, customers don't want a graph database. So why are we here? And for those who don't know me, I believe I've met many of you, but I'm Brad Bebee. I'm the general manager for Amazon Neptune and also Amazon TimeStream, which are two of our database services here at AWS. Prior to AWS, I was the CEO for BlazeGraph. Myself, along with Brian, Michael, and others, joined AWS, and we launched Neptune a few years later, and sort of away we go. I think we all agree that graphs are awesome. And what they allow you to do is use relationships in your data to solve problems. Graph applications are what customers do with these relationships to do something useful. We're here and we're interested because these problems are hard. Getting good performance on graph processing is hard due to random access, non-locality, other pieces. And in some way or another, we've all chosen to devote our research or businesses to building specialized systems or building capabilities that can help customers do this. Customers also think graphs are awesome. From my side, I'm super proud of the fact that every day, thousands of Neptune customers create tens of thousands of Neptune instances. And I know across all of the different companies and researchers indicated here, that number is even larger. And so we know that there's useful things that customers are doing and that customers really want to do with graphs. And it's really exciting. The kinds of things that customers are excited about, and these are old hat to all of you, things like knowledge graphs, identity graphs, fraud graphs, security graphs, your favorite pet rock graph, right? But what I found is that we don't even really need to say graph at all. Customers have data, and they have things they want to get out of that data. And for a lot of these problems, it turns out that using graphs is the fastest, cheapest, most effective, provides you a solution that you can't get in other ways. But what we give customers to do this are things like Tinkerpop and Sparkle and OpenCipher and GQL and a long list of other different things. And we ask them to make a lot of choices. We ask them to become graph experts. Sometimes we project our kind of graph cone head onto their business problem. And all that they really wanted to do was to use their data and get some kind of answer. So we always ask, how big is the business around graphs? And if you look at it one way, from customers who know that they want a graph database, customers who understand what property graph or RDF graph is, it's this one sort of relatively small dot. And when we look at the possibility, all of the different places that customers can benefit with graphs, it's a much, much larger space. And it's not just the things that we traditionally would think about from graph databases. It incorporates other different kinds of workloads. So it incorporates analytics, it incorporates graph-based machine learning, linked data, increasingly retrieval augmented generation applications, your latest thing here. So the opportunity is much, much larger when we put it in the context of the broader set of problems that customers want to solve. And for this group, as vendors, practitioners, researchers, we all win when more customers use graphs. We all win when there's broader understanding about the kinds of problems and the successes that people have. And there are some real challenges to customers being able to use graphs easily. I cherry-picked a couple in here. Congratulations for the property graph schema work. I think that's super important in this space. Standardized data interchange. Why don't we have a property graph interchange standard? Could we make it a lot easier for people to take data where they are at in data lakes and Parquet and project it into graphs in a way that would work across different vendors? That would help a lot of customers. We're all approaching different aspects of graph-based machine learning, GNNs, various different integrations with LLMs. If we can align approaches as we do language extensions and other pieces to give customers common APIs and common ways to do that, I think it's something that will benefit all of us. And of course, on the Neptune side, we made a very explicit choice to support both the RDF model and the property graph model. It's sort of part of inherently our belief. And so we see that we need to drive more interoperability across those. And of course, there's lots and lots of other things that customers can benefit from. But my sort of challenge to you is think about it in the terms of what customers are trying to do and think about usability and try and take on some of these challenges as we go through it. I know there's a lot of work being done across all of these different areas. So what about Gen AI? I believe that Gen AI is an inflection point for graph adoption. If you kind of cut through all the crap that's there. The reason is that I think that as a community, we've been looking at some of the problems that customers are going to encounter with Gen AI for a long time. We've been looking at them in different ways and under different names for 10, 20, 30 years, depending on how you look at it. And I genuinely believe that graph technologies are some of the best ways to solve some of these challenges. They're necessary for people to actually do useful things rather than just coming up with a demo. They're necessary for people to model their information domains to do useful things. And I think if we focus on use cases and usability, then we have a great opportunity as a group. So our vision for graphs on AWS is we want AWS to be the best place to store and manage customers' data and to solve challenges using graphs. We want to offer the broadest choice of services, partners, integrations to give people the most options. On the Neptune side, we believe that Neptune should be a great choice there, but it's not the only choice. And we want to embrace all of the folks who are doing great work to help people use graphs to solve problems, because that's fundamentally what we're about and why we're here. And for me, it's why I get up in the morning and get excited about these kinds of things. And I know why all of you are here at 9 a.m. on a Saturday in Seattle. And we also want to partner with you. If there's opportunities to show ways that customers can do things on AWS with your technology, with Neptune, with other things, we're here to help. We want to highlight those successes, because by highlighting and demonstrating ways that people are being successful, it'll help us drive and ground the research that we're doing. It'll help us grow the overall graph space. Oh, I can leave a picture. And so just to wrap it up, a rising tide floats all nodes and edges and triples too. So I would encourage you, let's do it. We've all been at it for a long time. Let's make graphs great and let's do it together. So thank you very much. And I've brought us back on schedule with a very brief talk. So if anybody has any questions, I'd be super happy to answer them. Denise, in the back, there's another microphone. If you could just grab that, that way that the people who are remote can hear the questions too. Just up in front. I'll come to you.
So you talked about the interchange. What is Neptune doing in terms of opening up pathways to move data back and forth to other products?
So Aura is going to give a talk this afternoon about how we're thinking about the model perspective of interoperability. For Neptune, we have a couple of different things that are built into the system. And we almost always see that graphs are not an island. When customers build things, a graph is a part of it. And typically it's not the main part. It might be the most important way that they get insights. So the kinds of features that Neptune has today, we have a change data capture mechanism, which we call streams, which effectively emits a quad with an extra attribute that indicates whether it was an addition or deletion, and you can use that to track the state of your graph. We also support, we have an open source utility that allows you to do exports out of Neptune, so if you want to export some or all of your graph. A common use case that customers do with that is export a subset of their graph to use to train DGL models and build GNNs, or do things like populate search indices if they want to do complementary graph and search kinds of use cases. And DMS. We also have support Neptune as a source in the AWS Data Migration Service, so you can take from a relational database and move it into Neptune. And as Michael points out, we support Sparkle Federation.
Thank you for the talk.
Can I ask a question online?
Yeah, go ahead.
Very thanks for the talk. So I'm kind of curious, among all the graph interfaces and languages you mentioned that Neptune supports, like Sparkle, OpenCipher, and Gremlin and stuff. So I'm curious, which ones are actually popular? Which ones are used, let's say, most often in the production?
They're all popular. So when we look across our customers, what we broadly see is that developers like property graphs. They tend to find it a natural and intuitive way to do it. And people who are thinking more of an information architecture kind of space tend to be drawn more towards RDF graphs. Usage-wise, when we look at the counts of property graph instances, we have much higher sort of usage on the property graph space than RDF and Sparkle. But the use cases are very different.
Yep, thank you. And I'm curious, for the property graph instances, any pain points they are experiencing, like let's say schema or schemaless or anything else you are seeing which can drive more adoption of property graphs? I'm kind of curious about your thoughts.
So I'll give you my view. I'm sure others here have their own, but I think that one of the things that I see would help a lot of property graph use cases is property graph federation. I think a lot of people in the property graph space don't think about the concepts of federation, and there's some good use cases and reasons, ranging from graph partitioning to some customers who need to keep their data in different locations for regulatory reasons. That federation would be super useful. Schema, of course, I think is very important. It's important for both data validation pieces as we're doing some of our own work, excuse me, with doing prompts and using LLMs to build and generate graph queries, we're finding that getting the schema information out of the graph is very important for you to be able to get build and give feedback into the prompts so that you can get better query results that are being generated. So I think as we see more of these kinds of RAG type use cases, that the schema will be very important there too.
Okay, thank you so much. So by the way, this is Bailey from Google. Thank you so much for the answer.
Sure, thank you.
So in LDBC, we have high transactional workloads, both the interactive one and the new bench. You have thousands of updates per second. Is this something that's representative of the workloads? Do you see this, or do you see more like read-heavy workloads in practice?
So across Neptune customers, and as most of you know, Neptune's architecture is focused on sort of traditional OLTP type processing systems. So we see a mix. I think that some of the larger workloads that we have, particularly in some of the entertainment space, do have high rates of transactions. In particular, we've seen very large growth, 300% in the security space. Those have very high update rates. So we do see those kinds of use cases. We also see use cases where people, the graph is not necessarily the system of record, and where they want to ask questions over it to augment other parts of their solutions.
Cool, thank you.
Can I ask one more question?
Go ahead.
Yeah, so I'm curious about the size distribution of the graphs, because there's some kind of common perception that graphs might be small, and maybe a single sharded, service might be enough. I'm kind of curious of what's kind of size distribution of the graphs like in real world.
It's a good question, because I think that on one hand we tend to be really interested in very big graph problems because they have some characteristics that are challenging. But when we look across all of our customers, most of the graphs are relatively small. If you look at it from a revenue perspective, most of the revenue comes from graphs that are much larger. But from the customer use case perspective, we really see that you want to make it easy to put small graphs in lots of different places and have a very low barrier to do that. And then in cases where those graphs grow, be able to bring along the compute, query, and storage capabilities to go with the customers so that they can sort of scale the graphs with confidence, if you will.
So Peter Mons from CWI. Very nice talk. So I was also very interested in what you mentioned about broader use cases with graphs, GNNs and RAG. So with GNNs, I suppose what you're talking about, people kind of preparing graphs and then training GNNs on them. Is there, after they train the GNN, is there also a use case for using graph data technology? Like is it querying what comes out of the GNN, or is that not something you've seen?
So the use case that we see most frequently with GNNs is using the embeddings for link prediction inside of different applications. We have something that's called Neptune ML, which is an integration with DGL, so you can export data, compute the embeddings. And then through extensions in both Gremlin and Sparkle, you can then ask for predictions or properties that would have been predicted or edges that would have been predicted by the GNNs. And so that's the most common use case that we see. I think there's some potential use cases that more of the DGL team has explored in terms of things like drug hypothesis repurposing types of things. There's some nice use cases in the Amazon product search where they're doing recommendations based on GNN computations over either graphs of user interest or graphs of product pieces. But I think that the link prediction is the dominant use case that we've seen there.